law of conservation of energy, we're gonna have number 21. So we have a toy cannon uses a spring to project 5.30 grams of rubber ball. The spring is originally compressed by 5 centimeters and has a force constant of 8 newtons per meter. When the cannon is fired, the ball moves 15 centimeters through the horizontal barrel of the cannon, and the barrel exerts a constant friction force of 0.032 newtons on the ball. Letter A. With what speed does the projectile leave the barrel of the cannon? Letter B. At what point does the ball have maximum speed? Letter C. What is the maximum speed? So let's have the representation here. So I already have the representation. So it says here that the initial the spring is compressed initially 5 centimeters, okay, and it travels 15 centimeters, so it's the length of the barrel. Next, we're gonna use law of conservation of energy to solve for the final velocity. Okay, so since we do not have any change in height, our change in potential energy is 0. Now, since the initial velocity is 0, therefore Ki is also 0, leaving us with this formula. So we have 1/2 m Vf squared is equal to, I'm gonna transpose this to the other side, work done by the spring, that's 1/2 K xi squared minus xf squared minus fkd. Okay, so as you see in the figure, xf is 0. Okay, so we have the formula 1/2 m Vf squared is equal to 1/2 of K xi squared minus fkd. Okay, so now let's have the formula for Vf. So Vf is the square root of 2 over m multiply with 1/2 K xi squared minus fkd. And then we just apply the parameters. Okay, so 2 over, so that's 5.3 grams. So 5.3 times 10 to the negative 3 kilograms. Okay, so 1/2 of 8 newtons per meter. Xi is negative 5 centimeters. So that's 0.05 meters squared minus, we are given the value of friction force as 0.032 newtons, and the distance it traveled, that's 15 centimeters, so that's 0.15 meters. Okay, so if we're going to solve that, we're gonna have Vf as 1.4008 meters per second. Going to illustrate it here. Isn't it our spring is compressed 5 centimeters from its original position? Okay, now we will say that the ball will stop speeding up when the spring force is equal to the friction force. So isn't it, we have this friction force and we also have this spring force. Okay, so now it would be in equilibrium, or it will stop speeding up if the spring force is equals the friction force. Therefore, friction force absolute value of friction force is equivalent to kx. So x is equivalent to spring force over k. We have 3.20 times 10 to negative 2 power Newton over 8 newtons per meter. Or you could simply say 0.032 newtons, which is the same. Now, solving this, we're gonna have 0.032 divided by 8 is 4 times 10 to the negative 3 or 4 millimeters. There. Okay, so from the initial position, okay, we're gonna solve now where the ball has moved 4 millimeters from the initial position. So we're gonna subtract minus 4 millimeters. So it's gonna give us 4.6 centimeters from the start. Okay, so that is where the ball has the maximum speed. Now, we're going to find out what is our maximum speed. Okay, so the initial position of our ball is negative 5 centimeters, and the final position would be 4 mm, negative 4 mm. Okay, and the distance is 4.6 centimeters from the start. Okay, so here's our working formula from the law of conservation of energy that we have derived earlier. And let's now substitute the given parameters. Okay, so we have 2 over 5 kilograms, 1/2 of 8 newtons per meter. Xi is negative 0.05 meters squared minus negative 0.004 meters squared minus 0.032 newtons, and the distance traveled is 0.046 meters. Okay, so the computation for this one would be equivalent to 1.79 meters per second. So this is the maximum speed. Right? For our second item, here is our given figure. The coefficient of friction between the block of mass M1, which has a mass of 3 kilograms, and the surface has a coefficient of kinetic friction of 0.4. The system starts from rest. Okay, so if it starts from rest, Vi is equal to 0, both for M1 and M2. V1I 0, V2I is also 0. Okay, so what is the speed of the ball which has a mass of 5 kilograms when it has fallen a distance of 1.5 meters? So this is 1.5 meters, and we're asking for V2F. Right. Okay, note here that if we're looking at M1, let us say this is our origin. Therefore, delta U1 is equal to 0. Okay, so we don't have any change in height. Okay, unlike here on our second object, we have a value for U1, but U2i. That's U2i. U2i. But for U2 final, it's equal to 0. Next, since our VI is 0 for the both ball or the both objects, therefore our K1i is 0. Same with K2i. It's also 0. This is from rest. Right? What else do we got here? That's it. Now let's keep moving. Since we're talking about two different objects, so our formula would be change in kinetic 1, okay, plus change in kinetic 2, alright, plus change in potential 1 plus change in potential 2 plus change in internal energy is equal to work done by other forces. Okay, on this case we do not have any other forces. Okay, so for as I have said, delta U1 is equal to 0. Okay, and for K1 we have K1 final minus K1 initial. For K2 we have K2 final minus K2 initial. For U2 we have U2 final minus U2 initial, okay, is equal to negative FKT. Okay, since 2i and 1i are both 0, so let's cancel them out, as well as U2F, that's also 0, leaving us with K1F plus K2F minus U2F is equal to negative KT. Yep. Now, for K1, our formula would be 1/2 of M1. Yep. And then the final velocity squared. For K2F, we have 1/2 M2, right? Final velocity of that object minus mgh, so M2 gravity and height 2. In this case it's 1.5 meters, is equal to negative FKD. So that's our working formula. And if we're going to take the free body diagram of our object, okay, so M1 is the only object that has friction here. So if we're going to take the free body diagram here, it's the weight and that's the normal force, therefore normal force is equal to weight. Okay, so let me copy this one. Okay, is now equivalent to negative mu kn, which is equivalent to mass times gravity, multiply with the distance. Alright, so if we're going to factor out VF and leave it on the other side, we're gonna have the formula for VF as 2 GH multiply with M2 minus mu K M1 over M1 plus M2. So let's now substitute the given parameters. Okay, so we have 2 times 9.8 meters per second squared, height of 1.5 meters, okay, M2 is equivalent to 5 kilograms minus 0.4 times 0. That's 3 kilograms. Okay. All over M1 as 5 kilograms plus 3 kilograms. Okay. So our final velocity will now be 10, equivalent to 3.74 meters per second.